The graph of f prime is below. Use it to determine where the local minima and maxima for f are. If there are multiple, separate with commas. Okay, so the determination of where we have minimums and maximums. If you're not reading carefully, you might look to, say, this point here and this point here. And the problem with that is we're not looking at the function itself. We're looking at the derivative of some function. So the way that we interpret this information is a little bit different. So a couple of things that we know here is that if we go from an interval, well, let's suppose we have a critical value. So we have a critical value, and we have an interval that is increasing, and then an interval that is decreasing. At this critical value, because we go from increasing over to decreasing, this has to be a relative maximum. So that's what we're looking for. First, where the critical values are, and then are we increasing or decreasing around that interval. And likewise, if we have a critical value where we go from decreasing and then change to increasing, well, decreasing to increasing gives us a shape like this, which means we would have a minimum value on that region. So let's first determine where we have critical values. All right, so critical values. These are going to occur whenever the first derivative is 0 or the first derivative is undefined. Now, since I have a continuous curve here, I don't think that I have any places where the first derivative is undefined, so I don't need to worry about that situation. But I have a few places where I have the first derivative being 0. So that is at this point here, and this point here. So critical values, I have -3, 1, and 4. Okay, so I'll put those values on a number line. Because if you put critical values on a number line in order, you can determine if you're increasing or decreasing from the graph. So remember, this is still the derivative, and we're increasing wherever the derivative is above the x-axis, so wherever the derivative is positive, and we're increasing here and here. So on the interval from -3 to 1, we are increasing, and from 4 to infinity, we are increasing as well. Now, on the interval where any interval where the derivative is less than 0, so below the x-axis, the original function is decreasing. So we're decreasing on the interval from negative infinity to -3, and then again from 1 to 4. And if you want to write these in as decreasing, decreasing, increasing, and increasing, that's perfectly fine. I just use the plus and minus for myself. However you work with that is no problem. Now, if we are changing from an interval that is decreasing to increasing, that's what shape would have to look like on the original function. This point right here, which is the critical value, has to be a minimum. Now, if I go from increasing to decreasing, this critical value that we cross has to be a maximum. And then we go from decreasing to increasing. As long as we're on a continuous curve, then this has to be a minimum. So the local minima are -3 and 4, and the maxima is 1. And I should specify that that is the locations of where the minimums and maximums occur. We don't actually have what the minimum and maximum values are. We'd have to have the original function in order to be able to determine that. But this is the locations of them.